Hey guys, this is for regular and honors. The honors questions are basically the same. You just have to do a little bit more factoring. You can still use the trick on everything. And there are two extra questions I added to the very end for honors that is honors only. So once the regular is done watching the video and you get to honors only, you're done. Anyways, number one, since the bottom is not factored and we need to simplify it, we're going to factor the bottom using Xbox. So on the top is 15, and the bottom is -8. So our two numbers to get 15 when you multiply and -8 when you add are 3 and 5, but they both need to be negative. So this becomes x minus 3 on top, and then on the bottom is x minus 3, x minus 5, because we got -3 and -5. So typically I would ask you, is there anything we can cancel out? And you would tell me, yes, it is the x minus 3's. So we are just left with 1 on top because it canceled out, and x minus 5 is still on the bottom. So our simplified version is just 1 over x minus 5, and our restrictions come from the denominator when we factored out. So we talked about how the canceled out is our wholes, which are restrictions, and the x minus 5 are our vertical asymptote. So your x cannot be +3 or +5, because if you were to set both of those equal to 0, you would get +3 and +5. So x cannot equal 3 or 5. Okay. Number 2, this is a multiplying problem. Don't forget, when you multiply across. So before we can multiply, we do have to factor the numerators. So this one, we have an 18 on top, 9 on the bottom. Which two numbers that we multiply to get 18 and add to get 9? 3 and 6. So this actually becomes x plus 3, x plus 6, over x plus 3, times, I can also factor the top. It does have a GCF of 5, so I'm left with, not 10, x minus 2, and x plus 6 on the bottom. So remember when we talked about multiplying across, I'm not going to make you rewrite all this out, so just pretend that that bar is closed, and we can cross out our x plus 6's and our x plus 3's. So really all we're left with is this 5 times x minus 2. Now if you did multiply that back out and got 5x minus 10, that's fine too. The restrictions always come from the denominator or your LCD. In this case, our denominator is x plus 3, x plus 6, or if we thought about it as being our LCD, x plus 3, x plus 6 still. So you were setting the bottoms equal to 0 and solving for the x's. So in the first case, again, you get x cannot be -3, and in the next one, if you subtract 6, you get x cannot be -6. Cannot be. Okay, for the next one, we have a dividing. Don't forget, dividing, the rule is keep, change, flip. Keep, change, and flip. So I'll show you. Before we can do this, we want to make sure everything's factored. So I do notice some things that we could factor on the numerator of the first one. We have a 2 as a GCF, and we would be left with x plus 4. And then also in the denominator of the second one, we could do xbox to simplify this. We have a 6 on top and a -5 on the bottom. So our two numbers do end up being -2 and -3. Which means that when you factor this, you get x minus 2 x minus 3. Now, since I have so much written right here, I'm going to rewrite this to where it looks better. So in the numerator, I had 2x plus 4. Then I had x plus 4, x minus 3. I'm supposed to change my sign to multiplication and then flip the next one. So since on the denominator I got x minus 2, x minus 3, that's going to become the numerator. And then my x minus 1 comes on the bottom. So before we cancel everything out, let's go ahead and list our restrictions. Remember, restrictions come from the bottom. So right now we see that we have x cannot equal negative 4, x cannot equal positive 3, and x cannot equal positive 1. So I'm getting all of those from the denominators. So x cannot equal negative 4, x cannot equal positive 3, and x cannot equal positive 1. But since it's division and we had to flip the second fraction, our restrictions also come from the numerator on the side we flipped. So x cannot be positive 2, and x cannot be positive 3 again. So that is a lot of restrictions, but we do have to list all those out. So we got negative 4, positive 3, positive 1, positive 2, and we got positive 3 again, but it's not necessary to write that twice. So just make for sure you understand where the denominators, or where the restrictions come from. So I'm going to erase this so we can finish our problem. Okay, so now again, since it is multiplying, we can kind of close that gap, and everything on the top and bottom that's the same, we can cancel out. So we have x plus 4s, x minus 3s, and that's it. So this actually becomes 2 times x minus 2 over, we have x minus 1 left. And at that point, nothing else can cancel out. You could simplify this by redistributing that 2 to get 2x minus 4 over x minus 1. If you left it before distributing, I would take that as your answer. But let's go ahead, just because simplifying it all the way is more correct. 2x minus 4 over x minus 1. Keep in mind, since these are subtracting now, you cannot just cross out the x's because they're on top of each other. You can only cross out factors that are the same. If there is a minus or plus sign in between them, you can't just cross those out. So that is the final answer. Okay, next problem again is another multiplying one. This time we are just simplifying. We do not have to worry about the restrictions or anything. So let's go ahead and factor our top. 8 on top, 6 on the bottom. Our two numbers are going to be 2 and 4. 2 times 4 is 8. 2 plus 4 is 6. So this actually becomes x plus 2, or sorry, we're using t's this time. T plus 2, t plus 4. And then we can also factor this part because it does have a GCF of 2. So when we factor out a 2, we're left with t minus 5. And at this point, I wouldn't take the time to rewrite all this. We know that this is multiplication, so we can just multiply across. We're just going to cross out anything that's the same on the top and bottom. So we can cross out our t plus 2s and our t minus 5s and our t plus 4s. So all we're left with is this 2 and t minus 5. So it is 2 over t minus 5. I think that was everything. Yep. Okay, next one is a division. Again, this one does not ask for the restrictions, so we are just simplifying. This first one is x squared minus 81. You should notice that that is a difference of perfect squares. The square root of 81 is positive 9 and negative 9. So this becomes x plus 9 and x minus 9. You should also notice that this part is a trinomial, which we can use Xbox to solve. 9 on the top, negative 10 on the bottom. It is going to be 1 and 9, with both of them being negative. So that becomes x minus 1 and x minus 9. Now in this case I would rewrite it because we do have division, and remember the rule for division is keep, change, flip. So we are keeping the first one. Changing the sign. And flipping the second one. That way we can kind of pretend like that's all on one line since we're just multiplying across at this point. And we can cross out the x plus 9s. We can cross out the x plus 1s. We can also cross out the x minus 1. And what do you notice? We can actually cross out everything here. So if you think about that, if we had something like 5 divided by 5, those both cancel out. What does it always equal? 1, right? Not 0, not nothing. It is 1. So same rule applies here. Even though all this stuff is canceled out, it actually equals 1. And I don't even know if you would put the x equals, you could just write 1, or you could put x equals 1. The answer is 1. You will have one like that on your test. Okay, number 6 is asking you to add or subtract and state any restrictions. So whenever you are adding and subtracting, you do need to find your LCD first and list your restrictions, and then go ahead and simplify. So we have a 4x and a 7y in our LCD. So that, sorry, I have hiccups. Our LCD is going to be, if you think about it, if we start with 7 plus 7 is 14. Well, 4 can't go into 14. We could try 21. That's not going to work either. So we're going to have to go ahead and use 28xy. Because 28 goes into 4 and 7. And then we also have an x and a y that needs to be in our LCD. To find our restrictions, we're just going to set the LCD equal to 0. And this is going to be kind of confusing on how to solve. So what might be easier is to think about this as all being multiplied. Since it's 28x and y. If you think about it as it all being multiplied together, you know you're just solving for the x and the y for your restrictions. 28 does not have anything to solve for, so we know that our restrictions are just x cannot equal 0 and y cannot equal 0. And now that we've got that done, we can go ahead and add and subtract. So we want our LCD to be 28xy. If you look at the first side, how do we get from 4x to 28xy? Well, we had to multiply by 7 and y. So what I do to the top, I also have to do, or sorry, the bottom, I also have to do the top. So 1 times 7y is just 7y. And then if you look at the other side, how did we get from 7y to 28xy? Well, we had to multiply by 4x. What I do to the bottom, I have to do the top. So x times 4x is 4x squared. At that point, you're just adding the numerators, so it becomes 7y plus 4x squared over 28xy. And again, I know you guys want to cross stuff out at that point, but those are not factors. There is an addition sign in the middle. You cannot just cancel stuff out anymore. This is the answer as simplified as it gets. Okay, number 7. This is another addition problem. So to find the LCD, we are going to have to factor this. Negative 18 on top, 7 on the bottom, 2 and 9 with a negative 2. So this becomes x minus 2, x plus 9. Which, if you notice, there is another x minus 2 in the other fraction. So your LCD is going to be x minus 2, x plus 9. And if we set both of these equal to 0 to find our restrictions, here we would have to add 2 to get x equals positive 2, and here we would have to subtract 9 to get x equals negative 9. So this is what x cannot equal in our denominator. Because if you think about this, if you plug those numbers into the denominator, you're going to divide by 0. And you cannot divide by 0. Reason why? Because it would become undefined. It is an error. Now, with that part aside, we are adding, so we need our denominators to be the same. So we want both of these to be x minus 2, x plus 9. X minus 2, x plus 9. Well, if you notice, when we factored the first one, we didn't change anything. So this 2 is not going to change. For the second one, we had to multiply an x plus 9. So we are also going to have to multiply x plus 9 to the top. And 1 times x plus 9 is just x plus 9. Now again, I know that you see this x plus 9 on the top and bottom, but we cannot just cancel those out because of this addition sign here. We're not just dividing and multiplying now. We are adding the tops and then dividing. But if you notice, when you do add the tops, you don't get just x plus 9. This now becomes x plus 11, which is not a factor that we have in the bottom. That is your final answer. All you can do is combine those like terms up top to get 11. Nothing cancels out after that. Okay, number 8 is a subtraction problem. Hopefully you already noticed that this part right here where it says n squared minus 9 is a difference of perfect squares. The square root of 9 is positive 3 and negative 3. So it's x plus 3. Oh, not x. Dealing with n's. N plus 3 and n minus 3. And luckily, the other fraction also has an n minus 3, so our LCD is just going to be n plus 3 and minus 3. And again, if you were to set those equal to 0, hopefully you can tell now that if you were to subtract 3 for the first one or add 3 to the next one, n just cannot equal negative 3 and positive 3. And the only reason I'm writing my restrictions now is just in case your question did ask you for the restrictions, you would know how to find them. Okay, at this point, we have n plus 3, n minus 3, and this time we are subtracting, and we want this one to be n plus 3, n minus 3. So again, the first fraction we didn't have to change anything to, so it's going to stay 5n. But the second one we had to multiply an n plus 3. So I'm also going to have to do that to the top. And when you do that, you do have to distribute the 3 this time, and it does become 3n plus 3. Now keep in mind here, this time it is subtraction. So I have 5n minus 3n, and then when you minus a positive, it becomes negative 3, which reduces to 2n minus 3 on your top. So this is 2n minus 3 over n plus 3 and minus 3. Okay, number 9. Ooh, this is the problem that you guys like. This is the work problem where we set up our people added together, and then equal them to how much they can do together. So you see that we have two people. We have a Susie and a Jill. So 1 over Susie plus 1 over Jill equals 1 over them together. Well, it says that Susie can plant a garden in 8 hours. And with the help of Jill, they can plant the garden in 5 hours together. Whoops, not that. 1 over together. 5 hours. So for Jill, it says, how long will it take Jill? So we don't know Jill. So Jill is X. At this point, you're just finding the LCD. The LCD between 8x and 5. I would just go ahead and use 40x, because 8 times 5 is 40. And then what you do with that LCD is you multiply all the numerators by the LCD. So times 40x, times 40x, times 40x. So this becomes 40x divided by 8 is 5x. 40x divided by x, the x's cancel out, it's just 40. And 40x divided by 5 is 8x. If you subtract the 5x's, you get 40 equals 3x, and divide by 3. So x equals 40 over 3, or you could write it as a decimal, which I don't have my calculator right now, so whatever you get as a decimal, I'm fine with. But we'll leave it in this case as 40 over 3, and it was hours. So if you got the decimal version, that is fine. I just don't have my calculator right now. Okay. Number 10, this is a proportion where we have fraction equals fraction, and we are trying to solve this for x. So I taught you guys using a proportion how to solve this. Don't forget, since we are solving, we do need to list our restrictions, because if we get an x value that is a restriction, it's no solution. So before we do this, let's solve both of our denominators for x by setting them equal to 0. And for the first one, you have to add 4 and then take the square root. So x equals positive 2 and negative 2 when you take the square root. And then for the next one, when we subtract 2, we also get negative 2. So your restrictions are x cannot equal positive 2 and negative 2. So again, we do this so that whenever we do solve the problem, if we get an x value that equals 2 or equals negative 2, we know that it's no solution. Okay, so now since this is fraction equals fraction, we know that we can use cross multiplication, which we are really good at. So 3 times x squared minus 4 equals 9 times x plus 2. Distribute. This becomes 3x squared minus 12 equals 9x plus 18. We're going to have to subtract the 9x. That becomes 3x squared minus 9x minus 12 equals 18. And then also subtract the 18. So we get 3x squared minus 9x minus 30 equals 0. Hopefully you notice this one's probably going to be a little bit harder now because we do have a trinomial. And since it's trinomial, we are going to have to use xbox. Okay, so you also should notice that there is a GCF, so we're going to be able to pull out a GCF of 3. And when you do that, you're left with x squared minus 3x minus 10 equals 0. Hopefully this works. Now we can do Xbox and we can use the trick conveniently, so let's do that over here. On the top we have negative 10, and on the bottom we have negative 3. Two numbers that multiply to give me 10, I know it's 2 and 5, and then to make it negative we can make a negative 5. Since it is able to use the trick because there's no number in front of the x squared, this would be x plus 2, x minus 5. Again, because it's these numbers with an x. The 3 out front, since it was our GCF, it doesn't really matter for this problem because we are just solving for the x values. So if we set these both equal to 0, hopefully you can tell that if we were to subtract 2, we would get negative 2. And if we were to add 5, we would get positive 5. And this is where you look back at your restriction. Okay, well it says x cannot be positive 2 or negative 2. So we cannot have negative 2 as an answer. X equals 5 is our only answer here. So that one was kind of a long one, but hopefully it wasn't too bad since we were able to cross multiply and just distribute. And we were able to use the trick. Always check your restrictions when you're done. Okay, number 11. Here we are adding and we again need to solve for x, so we need to see what our LCD is going to be. So for the last fraction I can see that I can factor out a 4. And I'd be left with x plus 2. And conveniently, my other two fractions also have a 4 and an x plus 2. So I know my LCD is going to be 4, x plus 2. And again, let's go ahead and write our restrictions so that we know at the end if we get an x value that is our restriction, it's not a solution. So again, the 4 is not going to matter because we're only solving for the x. So if we did solve x plus 2 and set that equal to 0, we do get x cannot be negative 2. So hopefully when we solve this, we don't get a negative 2. I told you guys the easiest way to do this was to multiply all the tops by the LCD. So I'm just like rewriting this out real quick. And then I'm going to multiply all the tops by our LCD, which is 4, x plus 2. 4, x plus 2. And 4, x plus 2. In the first one, we can cross out our x plus 2's. In the second one, we can cross out our 4's. And in the last one, we can cross out our 4's and our x plus 2's. So in the first one, we're left with 3x times 4, which is 12x. In the next one, we just have 1 times x plus 2, so it's just x plus 2. And then in the last one, we're just left with our 3, because everything else canceled out. And at this point, you're just simplifying and solving for x. So 12x plus x is 13x. Subtract your 2, you get 13x equals 1. And divide by 13. So x equals 1 over 13. Or you could write that as a decimal. I don't think we would take off points for that. It's fine to have a decimal. And again, check your restriction. X cannot equal negative 2, so 1/13 is a fine answer to have. Number 12, this is an easier one. It says, what is the equation of the vertical asymptote for the graph of f of x equals this equation? Don't forget your vertical asymptote always comes from the bottom. So it is this x minus 3 that you are setting equal to 0. So all you do is add 3, and x equals positive 3 is your answer. The x equals is very important for this one because it is going to be multiple choice, and there will be a multiple choice that says y equals. It is x equals for the vertical asymptote. It is a line, so it has to be an equation of a line. 13 is another that is going to be multiple choice and try to trick you. Horizontal asymptote is that Bobo, Botan, eats DC thing. So we have to decide if it's Bobo, Botan, or eats DC. And by doing that, we've got to look at the degree of the polynomials. Well, the top one just has a plain x, so we know that's an understood 1 as an exponent, so the degree is a 1. Same thing with the bottom. We have a plain x, so the exponent is a 1, so the degree is a 1. Which means exponents are the same, divide coefficients. Well, hopefully you notice the coefficients are 4 and 2. Remember, coefficients are the numbers in front of the x. So if we do 4 divided by 2, we get 2. Keep in mind this is going to be multiple choice, and it will have an x equals 2 and a y equals 2. You've got to know that horizontal asymptote is y equals 2. It is an equation of a line. Okay, number 14, we got to simplify and find all of these things. So, we have x on the top, and then on the bottom we have an x minus 6, because the GCF is an x. At this point, we have a factor of x on top and bottom, so those are going to cancel out, and we're left with 1 over x minus 6. Okay, so the simplified version is 1 over x minus 6. Your wholes, don't forget this is what you canceled out. Set equal to 0. So since we canceled out x, we're just setting x equal to 0. And there's really nothing to solve for. That's the answer. The x-intercept, you set the top equal to 0. The top is a 1. And 1 does not equal 0. There is no x to solve for, so this is none. The horizontal asymptote is where we look at the degree. The degree on the top, there is no x, so there is no exponent, so it's 0. And then on the bottom, we only have 1x with a degree of 1. Which means this is our bigger on bottom case, Bobo. The last O stands for y equals 0. Your vertical asymptote is the bottom set equal to 0. The bottom is x minus 6. So if you solve that for x, you're just adding the 6, which gives you x equals positive 6. And then the y-intercept, you're just plugging in 0 for x. So 0 minus 6, that gives us negative 1/6. Now again, for x-intercept and y-intercept, you could write this as an ordered pair. You could put x equals, you could put y equals, or you could just write the number. I'm really okay with any of that. For number 15, we do have to factor the top and the bottom. The top is going to be using x box. We have negative 15 on top, negative 2 on the bottom. So our two numbers are 3 and 5, where the 5 is going to be negative, which becomes x plus 3, x minus 5. And on the bottom, we have a GCF of 2x. So when we factor out a 2x, we're left with x minus 5. And hopefully you notice that the x minus 5s cancel out. So we are left with x plus 3 on top and 2x on the bottom. Your wholes is what canceled out. The canceled out was x minus 5, so we're setting that equal to 0 and solving for x. So we just add 5 to both sides. X equals positive 5. For the x-intercept, you set the top equal to 0. The top is x plus 3. So again, to solve for x, we're just subtracting 3. So x equals negative 3. The horizontal asymptote, you're looking at the degree. The degree on the top is just x to the first power, so 1. And on the bottom, x to the first power, still a 1. So remember, in this case, since it's the same, exponents are the same, divide coefficients. And in this case, the coefficient of the first x is just going to be 1, because there is no number. And the coefficient in the bottom is 2. So it's y equals 1 over 2, which happens to be a half. The vertical asymptote, you're setting the bottom equal to 0. The bottom is 2x. When you set that equal to 0, you divide by 2. 0 divided by 2 is just 0. So x equals 0. And then finally we have the y-intercept. The y-intercept, you plug in 0 for all the x's. So we have 0 plus 3 on the top and 2 times 0 on the bottom. 0 plus 3 is 3, and 2 times 0 is 0. Does anybody know what that means if I divide by 0? If you try plugging that in your calculator, it is going to say error. You cannot divide by 0. This is actually called undefined. There will be one like that on your test, so make for sure you know undefined is when you divide by 0. You get an error. The answer, if you put a 0 there, is going to be wrong. Okay, number 16, we're almost done. Number 16, this one I told you guys, the easiest thing to do probably would just be to plug these equations into your calculator and see which one most likely resembles it. Hopefully you will understand that it is not going to be a or b, because a and b is not a rational function, and this whole unit is on rational functions. So we can already cancel those out. If you are trying to determine it based on the graph, hopefully you notice that we have y-intercepts at, not y-intercepts, vertical asymptotes at -2 and +2. So in the factored form of this, it should be an x plus 2 and x minus 2, and both of these do have that. Now we just have to decide whether it's going to be 4 over that or 1 over that. And in this case, I'll plug it in the calculator. So, give me 1 second to do that. I feel like we're missing an x. Let's see. Don't forget, guys, if you're trying to plug this in the calculator, if you press alpha y equals, it helps you to get the fraction easier. Okay, so the 4 made it widen, and that 1 made it shrink. So if you did plug it in the calculator, the 1 with the 4 does, in fact, give you those x equals -2 and x equals +2 for the vertical asymptotes. If you plug in that 1, it actually makes the asymptotes at +1 and -1, which is not right. So it is going to be C. So again, for this one, I would rule out the ones that are not rational functions, and then plug the other two in the calculator. Easiest way to do it. Now for the rest of them, there are only 2 more, and these are only for honors, so if you have finished watching it and you're a regular, make sure you finish working on Alex, because it is due tonight, and finish your note card. Remember, you can only write in the bottom of that piece of paper, and you cannot write on the back. So anything you find helpful, make sure you write it down so you have it for your test tomorrow. If you do not bring it tomorrow, you're not going to be able to use it on the test, so make sure you have that. Okay? Honors only. Don't forget, for complex fractions, you are just finding the LCD and then multiplying all the numerators by the LCD. So the LCD is going to be 5b because all of the denominators have at least a 5 and a b. Your restrictions come from the LCD, so if you set this equal to 0, you do get b cannot be 0. And then if we multiply all the numerators by 5b, let's see what happens. Well, in the first one, both the 5b's cancel out. The second one, the b's cancel out. And the last one, the b's cancel out. So we are left with a plus 10a on the top, because 5 times 2a is 10a, divided by 5 times 2a again, so 10a. Now, I know you guys want to see these 10a's canceled out, but we cannot do that because the top is being added together. So this actually just becomes 11a over 10a. And technically we could cancel out the a's at that point, because now it is division, multiplying and then dividing. So our correct answer would be 11 over 10. But if you left it as 11a over 10a, I would give you that, that's fine. Okay, last one. We need to factor out the bottom using Xbox, -5 on top, 4 on the bottom. Your two numbers do end up being 1 and 5, with the 1 being a negative. So this does factor out to be x minus 1, x plus 5. So your LCD is going to be x minus 1, x plus 5, which means the restrictions are going to be x cannot equal positive 1 or negative 5. So at this point, we're just trying to make everything, we're trying to multiply the numerator by the LCD so that we can cancel stuff out. So x minus 1, x plus 5, x minus 1, x plus 5, x minus 1, x plus 5. And again, there are other ways to do this problem. I just feel like this way is the way to make the least mistakes, so that's why I do it this way. Cross out the x minus 1s, cross out the x plus 5s, we're just left with a 2, minus, here we can cross out the x plus 5, so we're left with 4x minus 1, but don't forget this is a minus, so it's minus 4x plus 4, because you have this negative, it's really saying -4 times -1, which makes positive 4. And then on the last one, we can cancel out the x minus 1s. So we're left with 3 times x plus 5, which becomes 3x plus 15. At this point, we can just combine our like terms. So we have -4x plus 6. I'm going to add my 4x, so I have a positive x. 6 equals x plus 15. And subtract my 15. X equals whatever 6 minus 15 is. I think it's 9, right? -9. And is -9 okay to have? Yes. Because it can only not be 1 and -5. Okay, so if you were struggling with anything, I would go back and rewatch the question, maybe try to slow it down some. This is due tomorrow for a grade, so make sure you do have everything written down. If you just have answers, it is not going to be full credit. You do need to have to show your work. Study tonight, get your ALEKS done, have a good day. See you tomorrow, bye.